Welcome to this explainer. Today, we are diving deep into Chapter 9 of our source material, which is all about understanding the agentic loop. And honestly, this is probably one of the most fascinating mechanisms in modern artificial intelligence right now. If you've been wondering how AI is making that massive leap from just answering simple one-off prompts to actually managing complex, multi-agent teams over days or even weeks, well, you are in exactly the right place. We're going to peel back the layers and unpack the incredible underlying architecture that makes true self-directed autonomy possible. Let's get right into it.
Okay, to really understand why we're going with this, it helps to first think about the inherent frustration of using a basic, out-of-the-box chatbot. You know the drill, right? A traditional generative assistant is highly, almost strictly reactive. It waits for you, it responds to your prompt, it generates an answer, and then it just stops. It completely powers down its train of thought. It basically forgets the overarching context of what you're doing unless you sit there and aggressively keep prompting it step by step. But how do you design a system that works toward a highly complex goal over multiple steps? A system that continuously chooses what to do next based on what it actually observes along the way? Well, the answer lies entirely in what we call the looping architecture. Understanding these loops is absolutely fundamentally the key to building real, robust AI workflows that can just operate independently in the background while you go grab a coffee. Here is our agenda for today. 1. The core agentic loop. 2. Layer 2, which covers task loops. 3. Deep research agents. 4. Layer 3, focusing on meta loops. 5. Orchestration and collaboration. And finally, 6. When to use loops.
Section 1. The core agentic loop, the inner workings of autonomy.
All right, at the very heart of a single autonomous agent is a cycle called Sense, Plan, Act, Learn, or SPAL for short. Think of this as the internal heartbeat of the AI. In this loop, Sense basically maps to processing the initial input and understanding the current context of the world. Plan is the reasoning model doing the heavy lifting, determining the logical next steps to take. Act is the physical execution of tools, like maybe running a Python script, sending an email, or querying a SQL database. And finally, we have Learn, which, if we're being honest, is perhaps the most critical phase of the entire cycle. This is where the evaluation of the output happens and the agent's working memory is updated. Imagine an agent trying to pull data from a website, but it hits a 404 error. In a rigid script, the whole thing just crashes, right? But with the Learn phase, the agent updates its memory, realizes the tool failed, and formulates a branding plan to find the information somewhere else. It evaluates its own results and decides for itself whether the core goal has been met or if it needs to spin up the loop and try again.
When we visualize this foundational Layer 1 loop, the really striking thing is how the goal, the plan, the tool, the state, and the decision elements all interact entirely within the agent's internal boundaries. It's totally self-contained. The agent receives a goal from the user, it holds its own internal state in its context window, it plans its tool use, and it internally decides when to terminate the loop. It is the agent itself driving the iteration, restricted only by the safety boundaries established by the developer. It's a beautifully elegant, self-contained system. But you have to ask yourself, what happens when the goal is simply too massive, too complex for this single internal process to handle?
Section 2. Layer 2. Task loops, stepping outside the agent.
So the big distinction between Layer 1 and Layer 2 really comes down to the horizon of the goal, and quite frankly, the physical limits of the AI model itself. Layer 1 is absolutely perfect for short horizon goals. We're talking about things with a narrow scope and a very clear immediate finish line, like summarizing a single PDF document or fixing a specific syntax bug in a short script. But a single internal loop simply cannot hold the context or manage the state required for long horizon goals. Think about it. If an agent loops internally for 6 hours researching a massive multi-industry market report, it will eventually hit a hard token limit. Its context window will just overflow. And when that happens, it starts to forget its earlier steps, it loses the plot, or worse, it starts hallucinating wild inaccuracies. So Layer 2 solves this by externalizing those core elements. It allows us to tackle broad scopes with evolving finish lines over days or even weeks without breaking the model's brain. When we scale up to Layer 2, a massive structural shift happens under the hood. The plan, the state, and the decision elements are ripped out of the agent and externalized. They are now managed by standard application code outside the AI model. In this setup, the agent itself effectively gets demoted. It becomes just one single tool inside a much larger external loop driven by code components. Now, this is absolutely vital from an engineering perspective. Why? Because the external code now dictates the iteration strategy and maintains what we call a state accumulator.
This accumulator actively dynamically manages the context window usage. It can compress, truncate, or summarize earlier findings as the loop progresses. This guarantees that the agent never gets overwhelmed by its own history, no matter how long it keeps running. Section 3. Deep Research Agents. Looping for Discovery.
To really ground this concept, let's think about a deep research loop. When you are building one of these Layer 2 research agents, there is a golden rule of separation of concerns, and it's a classic, painful beginner mistake to ignore it. Listen, it is extremely tempting to just have your research agent write the final formatted report on its very last iteration. It seems efficient, right? But if you do that, the agent starts optimizing for structure, grammar, and formatting during its exploration phase. This severely, measurably degrades its ability to actually explore the web and find high-quality information. You absolutely must keep them separate. The design pattern is this. The research agent loops continuously with one single job, to explore and discover. Only after it completely finishes and hits a wall does it pass its messy, raw findings to a totally separate synthesis agent. That synthesis agent then runs exactly once to compile, format, and structure the final polished output.
Section 4. Layer 3. Meta loops. Agents managing agents.
Okay, so once our goals become highly multifaceted and require distinctly different specialized skills, we graduate to Layer 3. This is where things get truly sci-fi level advanced. Because in Layer 3, traditional application code no longer controls the loop. Another AI agent does. In a meta loop, the decide, state, and plan elements are handed over to a controlling, overarching intelligence. And because a smart agent is now running the show instead of a rigid Python script, it can dynamically adapt to wild edge cases. For example, imagine a manager agent delegating the drafting of an important email to a specialized worker agent. When the draft comes back, the manager agent evaluates it, realizes the tone is way too informal for a strict corporate client, and autonomously sends it back to the worker for revision with new instructions. A standard, hard-coded programming loop simply cannot exercise that kind of nuanced, subjective judgment.
Now, depending on exactly how you place this controlling managerial agent, you end up with one of two very distinct multi-agent architectures. The first pattern is orchestration. This is where you have a highly centralized manager delegating tasks top-down to various worker agents. It's very corporate. The second pattern is collaboration, which is a much more free-form, organic passing of control between equal peers in a pool. Both of these are incredibly powerful tools to have in your kit, but they solve very different types of problems. To break that down a bit further, in an orchestrator loop, the manager agent encapsulates the decision-making and the overall state internally. It treats the subagents entirely as tools to be deployed when needed. It holds all the big picture context closely to its chest and simply asks the workers for highly specific outputs. But in a collaboration loop, control rotates among a pool of specialized peers who actually share those state and plan components. Think of it like they are all standing around looking at the same whiteboard. They can all see the shared state and they build on each other's work organically, contributing their own specialized skills when the time is right.
Section 5. Orchestration and Collaboration. Multi-agent architectures in action. Let's look closer at the orchestrator flow first. What makes this pattern so incredibly powerful in production is its strict, absolute separation of strategic reasoning from tactical execution. The orchestrating agent exists to manage the overarching complex goal and hold the state, but it never, ever actually touches a search tool or runs code directly. It sits above the fray. It exists purely to reason about what needs to happen next, and it delegates all the actual manual labor down to the specialized subagents. It behaves exactly like an effective human executive. This orchestrator agent plans the work by taking a massive, ambiguous goal and decomposing it into digestible, actionable subtasks. It then delegates those subtasks out to its specialized worker agents, waits for the responses, and then evaluates the returned results. And here is the real magic, the absolute superpower of this architecture. If a worker's findings reveal a complete dead end, or maybe they uncover unexpected new information that fundamentally changes the scope of the project, the orchestrator can dynamically replan mid-loop. It can literally just throw out the old plan, generate brand new subtasks, and pivot its entire strategy on the fly before ever moving to the final synthesis stage. Alternatively, in the collaborative meta-loop framework, there is absolutely no top-down manager bossing everyone around. Instead, a very lightweight turn manager simply cycles control through a pool of peer agents. What ties this whole swarm together is that they all read from and update a single shared state container. Each round of the loop builds on the collective work of the whole group. That means every single agent sees the full context, including all the specific contributions, the subtle nuances, and even the critiques from the other agents.
It's much less like a corporate hierarchy and much more like a highly dynamic, creative brainstorming session. This collaboration pattern absolutely shines when ambiguity is high. When there's no single, obvious, mathematically correct answer, you want a collaborative swarm. It frequently relies on a really powerful triad of specialized agents. First, you have a researcher agent that goes out and generates the initial findings. Then, a critic agent steps in. Its entire system prompt is dedicated to providing adversarial review. It relentlessly challenges assumptions and verifies the facts the researcher brought back. Finally, once the researcher and the critic reach a consensus, a synthesizer agent weaves those validated facts into a polished final output. This pattern matters immensely to your enterprise workflows because it's exactly how you build trust in AI systems. You are literally forcing the agents to fact-check and debate each other before ever presenting a human with a final, vetted answer.
Section 6. When to use loops. The pragmatic conclusion.
Look, we have seen some incredibly powerful architectural patterns today, but as with all engineering, it is absolutely vital to know when this architecture is actually warranted. You should absolutely leverage these loops for tasks like iterative discovery, where it's literally impossible to find all the information in one single search step. They are fantastic for progressive refinement, like iteratively reviewing and improving writing drafts. They work beautifully for handling batch processing queues, for navigating complex conditional branching in IT troubleshooting workflows, and for multi-source data aggregation. But, and this is a big but, you should rigorously avoid agentic loops for simple, single-task tasks. You really, truly do not need a multi-agent collaborative swarm just to format a CSV file or do basic sentiment analysis on a tweet. Adding a loop to a simple task just adds massive latency and unnecessary costs without improving the quality of the output one bit.
And that brings us to what is easily the most critical piece of advice from Chapter 9. I want to read this quote directly to you so it sinks in. Never deploy an agentic loop without both a hard iteration limit and a cost ceiling. An unconstrained loop is a production incident waiting to happen. Seriously, a poorly designed loop, one that lacks proper state management or crystal clear termination conditions, will just spin its wheels forever. There's nothing quite like the absolute horror of waking up on a Tuesday morning to a $500 API bill because your research agent got stuck in a logic loop, aggressively talking to itself all night long. Always, always, always mandate a hard iteration limit in your code.
Well, we have covered a massive amount of ground today in this explainer. We journeyed from the internal, micro-thought processes of a single agent in Layer 1 up through externalized task loops in Layer 2, all the way to orchestrating massive, collaborative swarms of specialized AI in Layer 3. The architecture to build truly autonomous, self-correcting systems is out there right now, and these engineering patterns are becoming clearer and more robust every single day. The technology is no longer the bottleneck. The only real question left for you is, what complex, time-consuming, previously impossible workflow are you going to automate first? Thanks for exploring Chapter 9 with me, and keep building.